Can you see my screen?
Yes. Yes.
Okay. I did some change and I'm not seeing what you see. Okay, I'll try to work on a few terms that we'll discuss about, and I think they are important on our, let's say, discussion for AI and DGGS. One term is about geospatial reasoning, and I took a source from Cartos, that is the ability of an AI system to understand a complex spatial problem independently, devise a multi-step analytical plan, execute it, and interpret the results to provide an actionable solution. It goes a bit more to the agent world. And if we see to other key insights, could be to provide some advanced problem solving, okay, make some data integration, have something beyond just simple visualization on a map. It is close to what we call geospatial foundation models, and somehow to provide actionable outcomes. One thing that at least throughout the pilot we found as necessary is to guardrail in geospatial world the AI, and here are some methods that we could do it through data validation, checks on what the system it gets in or out, static guardrailing, such using reference datasets to establish logical constraints, or dynamic guardrailing, compare predictions against trusted external models to identify anomalies. Another thing that we also discuss in a lot in the, not a lot, but we discuss it in the website, and we will have it also in the AR. It's about the AI orchestration. Can be referred how to manage and coordinate AI agents, primarily using the model context protocol. At least this is what we have now. We may in the future have more protocols on that. To connect with external data, tools, and systems, allowing complex tasks to be broken down to smaller, manageable steps, ensuring efficient workflows, data flow, and reliable business outcomes. And the key components here are the LLM by itself, the context, which is all the information that gets into the model, data and documents, the MCP protocol, which comprises by the host, the client, and the server we get the data, the host that runs the protocol, and the orchestrator, either it's an in-house software or a LangChain system or something else. And discussions that arise during the last pilot meetings was referring to discriminative versus generative AI and where we should focus upon. I understand that discriminative is more to what ML or DL is providing, and okay, Gen AI, you know. And I think we need both. Discriminative AI identifies current conditions like classifying road segments or safe or hazardous, while generative AI can synthesize these findings by producing evacuation plans based on simulated scenarios. So by combining this approach, the system can move from simply identifying what is to independently creating a solution for what to do. That is the context I thought of having in this discussion, and I'll pass to the first question, which is mainly the question provided by Jim, and we thank Jim for that. It appears that there was an intuition that DGS would be particularly well suited to AI systems. Did initial intuitions hold up where they found to be true, or perhaps the experience in the initiative suggested that they could be made true? They are true, or they can be made true. Looking for volunteers to initiate the discussion. Jim, do you want to comment on your question?
Well, only that it was actually a sincere question. The idea of again, I've done geospatial reasoning for a long time, automated reasoning for a long time, but not in DGGS. So I tend to think, well, okay, so what is the payoff? And I'd really like to have that sort of quantified, or at least more anecdotes about it.
Jerome?
Yeah, so I'm hoping someone else who actually work on the AI aspect in the pilot will comment, but since no volunteers, so I just want to repeat my suggestion earlier. It's not what we did in the pilot, but I really think that vision transformers is, and that's kind of a light bulb that went on this morning. I think the subzone concept would really be great to kind of be a general way to do the vision transformer approach, kind of get the attention of the different subzones talking to each other so that the LLM can see what is in the parent tile and do this and aggregate that to the cursor level, or the other way around. You start coarse and then you keep refining. But for this, we would need to train the actual model would need to be trained in the context of a specific DGGRS. So you would need to train a different DGGRS for each one. But I really think that would be a really powerful thing to explore in a future pilot. So Dean has a comment, I think.
Thank you.
Yeah, again, I would sort of defer to the folks that actually had the AI clients. So, you know, my impression was working with TerraFrame that the DGGS did definitely add value, because it kind of kicked off the processing in terms of figuring out where the initial high flood risk areas were, and then they could feed that into their spatial knowledge graph and then figure out what the downstream effects were. So, but in terms of, you know, that's still fairly prescriptive. You know, the orchestration is kind of prescribed in that case. We have sort of this whole predefined chain of dependencies of looking for flood risk first, and then what are the downstream effects. Whereas allowing an AI to kind of more freeform explore, let's say if you have a natural language question about what are the natural hazards in this region, then to Jerome's idea of this, you know, vision transformers of drilling into different zones and then using those zone IDs to query across multiple domain DGS services and kind of scout around for risk. That, yeah, I'm a bit more fuzzy. I think that's all doable. That's kind of the potential, but I think that level of sort of freeform orchestration, we didn't really have as much time to get into. And I think also the idea of an SLM, so that's in between LLM and just kind of procedural. So a simple language model, or what you were, I can't remember the term for, not a general, but a simpler, more focused domain specific model could have a finite.
Geospatial foundation model.
Well, I wasn't thinking so much geospatial foundation model. It's
domain.
Can't remember the right term. Yeah, like a domain specific model, or you can create models that you can train for a specific domain, and then that model would be aware of, let's say, a few dozen DGGS services that are relevant, but would still be free to sort of game through those, or you could do training on them for different disaster scenarios. So I think that's sort of an area worth exploring.
So if I understand the answer is that it holds up, they are true, but not exactly, but they can also make more true. If I answer the question.
Yeah, I think we made a good start, but
yeah,
certainly, yeah, it could be made more true with more development.
Move on.
Hi, this is Nathan. My hand raising function is not working on my Teams client, so later I'm going to jump off and then jump back on. Otherwise, I would have raised my hand. Yeah, so I think regarding your question, when it comes to AI systems, I mean, we have been exploring these large language models, and have, I think, experienced some of the limitations there from a findability standpoint. It's just, there's no question that there's great value here. But when it comes to the field of geospatial foundation models, and other, there are models that exist that are not text-based, and so I don't fully understand what that means, but that is something I am looking into, because I think we need a different paradigm if we're going to have a model reason about the actual contents within these DGGS zones, and especially when you're combining values from different sources, from different domains. I think there's just a lot of research that needs to happen there.
Yeah, I would add to that maybe the models are not only about data, but also about the actual logic that needs the specific domain or the phenomenon to handle upon. So it's not only about having tokenization about the specific data sets that may be needed, but also knowledge about the physics of the field domain that we need to take care of. All right, I'll go to the next question. What kind of AI were we most interested in, worried about, or focused on? Generative AI, foundation, neural net models, especially language-based systems with relatively unconstrained prompts as inputs, or discriminative neural net models trained to recognize some class of events of interest by generalizing from a set of examples of the events, or more crisply defined and natural net systems, just as knowledge graphs, ontology-based systems, etc. Jim, do you want to comment on this question? Or someone else?
Yes, I think you kind of sort of presented this idea that we kind of need the discriminative and the generative AI both used.
Yeah, I touched upon the last slide. I think that I think we need both. Well, it depends on the context of where we want to apply the AI system, but there is some good sense that we may need both. The discriminative to understand what is the current situation, and the generative in order to provide us some insights that we could not understand or could not find from the past, and we need to find solutions that are on a phenomenon that is in front of us. At least this might.
Correct me if I'm wrong. I think we did the third option, which is more crisply defined, basically knowledge graph or ontology-based systems, because we kind of controlled the questions. That was my take on this question.
Yeah, I think we touched upon the third. I think in our system we touched about the second, and at the end we tried to touch on the first one. But okay, that is something that we may need to do in the future a lot more. I see some hands raised. First is Jerome, please.
Sorry for repeating myself, but I think we do need to add to the list. It's kind of going in the first category, but specifically, I think vision transformers, and also Michael mentioned GNN. I think it's graph neural nets. So I think we should specifically consider this for future work.
Mm-hmm. And Dean.
Yeah, so it's kind of two different levels of the question. So in terms of what we actually did, I think I agree that using knowledge graphs and stuff. So that's the more crisp models. That's obviously something we did in this pilot. We still did use the Gen AI LLM stuff, as Justin and others pointed out, for the chat bots, for the chat front end. So to convert natural language into queries for DGGS or for knowledge graph. So at that level, we used LLM. I think one thing we should add to the list is SLM, because my understanding of SLM, the simple language models. So I think we don't just need, a general geographic models, but we also, for the domain knowledge, an SLM can be configured specifically for dealing with natural hazards. And so it would have resources and data, and perhaps some of those kind of ontologies and dependencies, okay, if you're looking for flood information, you need this type of information. So you can pre-configure an SLM with information so that it has a bit more context to that specialized area. So that's something we really didn't look at all in this context with the SLMs. And, again, in general with OGC, we're pretty good at standards around integrating data, integrating schema, integrating services. We're less good at defining standards around domains. So an exception to that would be sort of the muddy effort, because in that effort, we're dealing with sort of a digital twin of the underground utilities. And so there's a lot of domain-specific stuff around utilities in muddy. But outside of that, we haven't really articulated either the ontologies, schemas, or dependencies associated with, let's say, natural hazards or other types of like public safety risks.
All right, Lucio.
Yes, confirming what. Thank you, Dean, for what you just said. SLLM is a good asset in this. To my understanding and to my experience, the extraction of information out of imagery, or when you are sketching information, creating a vector database for roads or for any other infrastructure, you have a certain guidelines that you should apply to extract this information. So you are increasing the quality of the data derived out of this extraction mechanism. Using this and applying the same extraction guidelines for the results somehow of the artificial intelligence, also small dedicated local language model, not using the 8 billion, 10 billion term of Oyama or any other large language model, you obtain more trustable results with a certain degree of scoring of the information and so on. But if we are able at OGC to refine this and to find the rules how to do this in a proper way, as Dean said, for specific argument, for specific phenomenon or context, we are able to increase the trustness of the people on the geospatial information fused also with artificial intelligence data. Keeping in mind that we need to have the provenance of this information quite clear, authenticity of the information, and so on and so forth. So that's it.
Thank you, Lucio. The next question is, what would DGGS seem to offer the specific kind of AI systems we focused on? Someone wants to comment on that? Is the question clear? Maybe not.
Not much.
Not much. I'll move to the next one. Gen AI systems seem to use a semantics defined by its associations in vast, high-dimensional, semi-continuous vector spaces. The semantics of DGGS, on the other hand, depends on crisp representation in an explicit space of iconic representation. Did this represent a problem, an advantage, an opportunity? What do you think? I think we are discussing again about the glue between Gen AI and DGGS, but
Yeah, this is Jim. I apologize for dropping away. I had serious microphone issues going on. Hopefully, I wasn't causing echoes over there or anything. Yeah, it sounded to me like this was being addressed earlier when we were talking about the my parlance, discriminative versus Gen AI, and that there's a lot to do still in Gen AI. That's a much more challenging arena, and it seems to be taking the world by storm. So it seems important for us to get our this technology wrapped around that.
yeah. Well, in our discussion, I think we need to see our world on the edge of generative AI and discriminative AI. So somehow both have advantages, and depending the context of the use case, we need to touch both worlds. Generative AI can produce new information, new context, but we still need some knowledge on what happened and analyze the past. I see more hands coming up. I think first is Jerome.
Yes, just again, just mentioning that. So when we talk about Gen AI, I guess in the context of what we did in the pilot, what we were generating was mostly text, and I guess in some cases some maps. And then we talk about discrimination, but like the vision aspect, I think is really a key thing that the future pilot we should focus on a bit more, because that's kind of the actual analysis part. So I'm curious what you guys, kind of throwing another question here. How does this fit within what you guys were doing in the client? Like maybe we need more of that vision aspect in order to really answer the query question.
Right. Nathan.
Yeah, I was wondering, has anyone come across a paper or an article that talks about what representing quantized values in DGGS zones in a vector database, what that means? Because you certainly can do it, but I just don't understand how the vector space will help us with determining similarity. Because when it comes to text, concepts that have similar meaning are represented very close to each other within a vector space. But when it comes to the location of the cells, the granularity, the domain, and the values, to what extent can you represent? Of course, you can represent that in a vector database, but it's not clear to me what that means. And if anyone has come across anything that speaks to that, I would be very interested in reading that.
I think Michael before talked about tokenization of geospatial information, and this may be different from text vectorization. I don't know, Michael, do you want to comment on that more?
Yeah, thank you. I'm skipping the line here. Nathan, yeah. So I don't have a resource that you could read on this. The way I always saw it is like, okay, the grid system itself is, for me, it's a graph, right? You know the neighbors, you know the hierarchy, you know the children and the parents. So this kind of, for me, is very well suited for a graph neural network, right? And then the vector is essentially the values that you accumulate per zone. So if you have climate data there, if you have population data there, all this information is associated with zone ID, and that to me becomes a vector, right? And then you can do similarity analysis and figure out, okay, where are zones that have sort of a similar profile? I always named these things then a spatial token or a digital fingerprint. Each of these zone IDs has sort of a digital fingerprint, and you can match, and yeah, well, fingerprint would be unique, right? But you could find similar fingerprints in terms of the data context that this particular zone has. Again, sorry, I don't have a specific resource for that, but that's how I sort of conceptualize it.
Okay, so the similarity would be the granularity, the zone ID or similar zone IDs. That's the spatial similarity. and then the domain would also be another aspect of similarity. If I'm understanding correctly.
The similarity across the values at that location. So the similarity of population density, temperature, height over 0, and whatever other value you put there. I see, and that was my earlier comment. DGGS really, to me, shows its benefits when it's at scale. If you're working with just 1 or 2 data sets, it's not really worth it to go to a DGGS. Once you really integrate 10 plus 100, 400 data sets, or that's what I had in my paper, if you go to a lot more, you can describe that one zone with all these properties. And then what becomes more relevant, I think, is then you need the ontology, right? What does that value here, that specific column sort of in my data set mean, and how does it relate to the others to really get a full picture? But the vector to me would be the zone ID as the identifier, and then all the values sort of in the columns that are associated with that zone ID.
Yeah, and all the more useful it would be to have the value description mapped to a formalized ontology, like you said, so we can derive in the vector space semantic meaning. So when I say population in my question, there's in vector space it has an idea of what you mean by that.
Absolutely. This is also, I wrote it in the chat only as a comment. We cannot just throw all the data at the system and let the AI figure it out. We need to tell it an ontology. What does it mean and how does it relate? Yeah. If I talk about population, it may mean something completely different. So all this needs to be defined and part of the algorithm. Yeah.
Okay.
Lucio, do you want to comment on the ontologies?
Yes, what just the last person, I remember this, the name, sorry, said, confirmed. I mean, what we have to do here is to try to decouple, to transform the information, the textual information in vector, in graph, with an ontology, and see if small is better. So at the real end, we are able to chunk all the data in a certain way that all the information is managed by a sort of a graph database, where we can finally merge all this information. In this, DGGS is helping, and also the fact that they have to chunk all the information, as I wrote in the chat, in a way that we are able to extract out of this a graph for the information itself. But for this, you need ontology, but because you add each time new information, you can add, if you query, you add also information, you need something more dynamic to have the result properly fitting the purpose.
Thank you. Dean? Dean, we cannot hear you.
Yeah, just going back to the original, thanks. Going back to the original question, I don't think we had a necessarily that it presented a problem going from Gen AI or going from the general to specific, but I'm not sure that we really iterated through that. So what I mean by that is, from the Gen AI, let's say the LLM perspective, you ask a question in terms of, flood risk near Winnipeg, and then we have, based on what I understand how Terraframe's flow works, they have jurisdictional areas. So when you have those named areas, then you get a polygon, and so that's a very kind of prescriptive way of converting from the Gen AI's place name into a vector area, which then can be indexed against and find a bunch of zone IDs. And then from those zone IDs, we can do some queries and figure out downstream effects. But that's kind of a one-way trip when we did it in this pilot. I think the real power would be, once you have those zone IDs, now the LLM or the Gen AI can now make additional queries based on those zone IDs. In order to do that intelligently, like you guys are saying, you need an ontology. You may need to provide the whole DGS spec to the Gen AI. You need the ontology, and I don't know if not understanding exactly how these things are configured, the Gen AI itself might need some experience with DGGS to actually start to be more successful with it. But anyway, over time, you would hope that this would be an iterative process so that the zone IDs just become links to information the way that an address might be a link to information, and then it can accumulate information around those zone IDs and their subzones. So, you know, how much information, how do we end up training the LLMs to do this properly? Or is it going to be easier to train an SLM? That I have no idea. I don't think we really explored that, but I think there's a lot of potential there of having these integrations between CRISP and more general type AI models.
Just to
Thanks.
comment on that, in our pilot, in our use case, in our agent, we vectorized the standard, the DGS standard, and the libraries of DGGAL. So we gave them as food, in order to understand. We trained the model, trained in quotes, what is the new standard and what is the library that we tested in our pilot. I understand that the replies that we got from the system after we gave them this information was better than before, but we didn't do a proper testing on that in order to see before RAG information, giving the vectorized information to the model, and after that. But my feeling is that the LLM system behaved better, DGGS aware, after having the RAG information. Sorry for the comment, Jerome.
Yes, so yeah, sorry to repeat myself again, but really what I feel is the missing piece, and yes, the LLM can understand the zone IDs to some extent, but I think really what we need to do, and I think this is how the foundational geospatial models are working, is essentially they're doing it with rectilinear, and now we're just generalizing it to other DGGRS. So to answer Nathan's question earlier about how you can make some semantic sense of these vector spaces. So first you have the vector spaces about the actual values, right? So if you're analyzing like an elevation data set, for example, it's kind of making sense of that with the semantics. So you have the semantic aspect of the values, but then you also have like the relative, the relation between the different zones around. So if we focus on training on an ancestral zone and the subzone, and we really focus on this concept of subzones, which is just like a regular like grid in a rectilinear tile, for example, like in a regular image vision. So if we extend this like for hexagon grids, for example, then the system is able to make sense. So it what it does is it analyzes the value. So first you tokenize them to the individual subzones, and then when you train the model, you help it to make sense of what is next to each thing. So each token, which is an individual subzone value, gets imbued with what is around it. So that's what the whole attention is about the big transformer paper, right? It's imbuing each token with the tokens around it. And then what you do with the transformers is you alternate the attention layer with the perceptron layer, and you repeat this a few times, right? So that's kind of how you build this whole neural net for vision. And that's really the approach that I think would really make DGGS shine, especially when we get with the hexagons where you have like 6 neighbors, more regular neighbors. So I think that would be really, really powerful, and that would be really interesting to test. And this is kind of how you can, so that's the vision aspect. How can the system really make sense of what it sees, and then you can repeat this at progressive level, either drilling down or building, aggregating back up to a coarser level.
I will read I want to add a quick comment to that. One thing I think, and I saw it in the chat earlier, but I think one aspect of all this that's important, I like this visioning aspect, but in order for the LLMs to understand which data sources are relevant for this visioning, one aspect I think we really haven't explored that much, maybe in future pilots, would be what sort of metadata does a DGGS service need to provide so that ontologies, or, you know, for context, you know, is this service worth querying? So you don't want to even bother querying the service down to the zone level if if the data is not relevant to that query. So I think we kind of have to have some domain-specific metadata for the services that are consistent, maybe standardized by OGC, so that AI's querying for different services don't actually have to drill into the zones to figure out if there's relevant information there. Just a thought.
I felt that we needed also metadata regarding the collections and the cataloging of the data that existed in a server or in multiple servers. So understand that the metadata should be relevant to the ontologies, but also relevant to the cataloging of the data. And I'll wrap up here. I'll read the comment of Jim saying that Jerome, please wrote these ideas about vision transformer and DGGS in the ER. So I would welcome Jerome to add a section on the ER about these great ideas. And I will wrap up this panel, and I will thank all of you for contributing to the discussion, and I will give back the floor to Sina. Thank you.
Thank you, Stelios. And yeah, we are 9 minutes over, so I won't hold you more as much as I like to. This is great discussions. Thank you again for joining today's and yesterday's workshop. I hope you enjoyed it. The recordings will be public. I'll try to figure out a way to make them public, and hopefully you enjoyed it, and we will see you on another events in OGC. Thank you.
Thank you.
Thank you very much.
Thanks, Sina.
Thank you.
Thanks, everybody.
Thank you.
Good job, all.
Thank you.
Bye-bye.
Thanks, everyone.
Bye.